Okay, so now that we've explored the confidence interval construction symbolically and abstractly, let's actually get into some details with an example. So in this example, we're revisiting the Marshmallow Test, which was recently, within the last 10 years, not exactly replicated, but the conditions of the experiment were repeated. A couple of different independent studies to see if the results hold up and if it can be replicated. Overwhelmingly, the result, which I link an article in the textbook, have been very distinct from the original results, which is that when you account for certain factors, the Marshmallow Test actually is an indicator of affluence more than anything else, not an indicator for intrinsic superiority of some children over others. So in this particular study, with a sample of 900 children, 335 wait to receive the second marshmallow. So if you remember, waiting to receive the second marshmallow means that they wait for 5 to 10 minutes, and the marshmallow that's sitting in front of them, they don't eat it. And then the experimenters return, and they can eat both of them. So what our task is going to be is to construct a 90% confidence interval for the proportion of children out of all possible children who wait for the second marshmallow. All right, so what do we need? So we extract from this scenario a few important pieces of information. So namely, we have our sample size. So conditions. Our sample size is 900. We are given that out of those 900, 335 are the ones in our group of interest, 335. And we can combine those two things together to find the sample proportion, our point estimate. So that's our 335 out of 900. And that's 0.372. Okay, so keep that in your mind, that roughly we're looking at about 37%. Okay, so that's our point estimate, but we want the confidence interval constructed around this point estimate. Now we're given that our level of our confidence level, or 1 minus alpha, is 90%, so 0.90. This we can also manipulate to find out what alpha has to be. Okay, so alpha's 0.10. In these scenarios, it's possible that you're given either the confidence level itself or the alpha level. Both should be able to be used to find the other, and you'll need them for finding the critical value for this confidence interval. All right, so now we can find some other additional summary statistics and pieces of information. Namely, we're going to find the critical value. Okay, so critical value. So z of alpha over 2, remember that's the 0.05 critical value, which is, in other words, the 95th percentile of the standard normal distribution. Now, you don't need to memorize these values. You can choose to memorize a few of the important ones for the standard normal distribution, but you should be able to use the table fairly quickly or even use invnorm to find these values. And you can pause here if you'd like, but I will tell you that our critical value then is 1.645. Okay, so now we can construct the margin of error. So that's E, and remember that that's our critical value times the square root of the sample proportion times 1 minus the sample proportion divided by n. Okay. One really important note here that I probably should have started with. In our conditions, right? Remember, we're supposed to check that we're able to use this method because n is greater than 20, and n times p hat is greater than 5, and n times 1 minus p hat is greater than... All that, when you have these large numbers, they're pretty much guaranteed, right? So sample size is definitely large enough, x is large enough, n minus x is large enough, it all checks out. There are some borderline cases that we'll explore, but by and large, once you have numbers this large, it's not an issue. All right, back to the main event then. Sorry. Then we fill in what we have, right? So 1.645. A hint here about what to expect when we're constructing the margin of error. So remember that the percentiles, right, of z, the larger the, the smaller alpha is, right, or the larger the confidence level is, the larger the corresponding critical value should be, right? So the 99th percentile would be something larger than this value. So your confidence level, remember from the last video, is proportional to, or not directly proportional, but tends to go up the same as the margin of error tends to go up. So larger critical value, larger margin of error. Now, the sample proportion, we can't do anything about that. But also, the sample size, the larger the sample size, the smaller the margin of error. So there's a trade-off here. And our sample size, of course, here is 900. And then take a minute to calculate that if you wish. You'll know you did this correctly if you can reasonably assume that this would be something small, right? So this is approximately 0.028. For standard purposes, we will usually go just to 3 places after the decimal. And so our confidence level, our confidence interval itself is remember, that's p hat minus e, p hat plus e. So we're looking at 0.372 minus 0.028 and 0.372 plus 0.028. And this is 0.345, 0.400. Okay, so if you wanted to restate this, right, in a sentence, if you wanted to report this finding, we would say we are 90% confident, because that's the confidence level, that the proportion lies between 34.5% and 40.0%, with an estimate of, or I should say point estimate, of 37.2%. And that wraps up not only the margin of error, but also the point estimate. And of course, we've seen another way of writing this, which is we can also say with 90% confidence, we estimate P is approximately 37.2%. If you're writing it as a percentage, of course, you can write it as percentage or proportion, just keep it consistent. And the margin of error, so these are alternative statements. You can use either the top one or the bottom one, is plus or minus our confidence, our margin of error estimate. So that was 2.8%, which is a typical way of expressing a confidence interval as well. So to recap, purely mathematical confidence interval expression. Here we have the exact same expression, just expressed in words. And here we have the expression in terms of the point estimate and the margin of error, given as plus or minus 2.8%. Right? So the basic instruction is very similar across the board. So remember, what are the steps here then? So our steps for calculating a confidence interval, okay? So step one. Do we know what we're looking for, right? So identify the objective. So if we're seeking to find a confidence interval, that's our objective. Two, we need to check that the sample satisfies the conditions. That n is greater than or equal to 20, that np hat is greater than or equal to 5, and n1 minus p hat is also greater than or equal to 5. If we don't have those, we can't use this method here, okay? So find the summary statistics, namely the point estimate, p hat, if it's not given to you already. That's kind of wrapped up into checking that the samples satisfies these conditions. 4, calculate the critical value, z sub alpha 2 over 2. Calculate the margin of error, and then put together the confidence interval. And if you're using a calculator, right, these steps right here can be used using 1 prop z interval in the tests menu of the TI-84.